respected Chairman ISRO, Shri.S Somanath, our Keynote Speaker, Dr.V R Lalithambika, our eminent panelists, esteemed ISRO and Indian Air Force dignitaries, IST faculty, students and fellow alumni. A very good morning to all of you. It gives us immense pride to present to you a panel discussion on the topic, Women and Spaceflight, Charting the Future. This event is being conducted in celebration of International Women's Day 2022, which was on March 8th. On behalf of the IISTAA Alumni Association, I, Ankita, extend a hearty welcome to all of you. I request the panelists and the dignitaries to kindly turn their cameras on, if it is possible. The Alumni Association of Indian Institute of Space Science and Technology is a 2,000-odd strong body with graduates from various fields at various levels. About half of all BTech graduates from IIST work as scientist engineers across various centers under the Department of Space and ISRO. Apart from this, IIST alumni are also contributing towards cutting-edge research in universities in India and abroad. They have also ventured into the challenging fields of business, administration, and entrepreneurship, and are contributing actively to the private space sector in the recent years. Coming to the topic for today's panel discussion, Women and Spaceflight. The topic was chosen keeping in line with the theme for International Women's Day 2022, Gender Equality Today for a Sustainable Tomorrow. This session seeks to understand the present scenario of human spaceflight in India, ranging right from the design of the prestigious Gaganyaan mission of ISRO, flight training for pilots and astronauts, and the monitoring of human health in manned missions. We now begin with the keynote address for the day by Dr. V R Lalithambika, former Director of the Directorate of Human Space Program, ISRO. Dr. Lalithambika is a specialist in advanced launch vehicle technology with focus on rocket control and guidance. She has had a highly illustrious career, and it is our privilege to have us here with us. I request ma'am to kindly deliver the keynote address.
Thank you very much, Anita, for that introduction. Respected Chairman ISRO, Shri.S Somanath, all the panelists, IISTAA alumni, and all other participants, good morning to you all. It is a pleasure to be associated with this event, and I thank IISTAA Alumni Association for facilitating it. It is also very good to see the carefully chosen panelists representing various areas associated with aerospace and spaceflight. And the structure of the event is totally in consonance with the International Women's Day 2022 theme and gender equality in STEM areas, which includes the space domain. It is definitely needed to achieve the sustainable development goals set by the United Nations. Now, women have been part and parcel of the space programs of all the spacefaring nations, and this includes our own program as well, right from the very beginning. If you look at the public perception, in the public perception, space flight is actually going to space and being in space. And that really grabs all the eyeballs, as we have seen. And of course, women have been very good here, and they have set records for spacewalks. We have had a long duration space flight, women records there, and they have commanded the International Space Station. They have also commanded the space shuttle. And this is all, as women, we are proud that all such things have been achieved. But as we all know, all of us who have been really working in this area, spaceflight involves much more than actually going to space. And women have been all along involved in the entire gamut of activities, all the related activities as well, like the research that goes into the space domain, the actual execution, realization of both the ground segment as well as the space segment. And historically, if we are looking at the US, I mean, that's like a benchmark, it is considered that women in research as well as women in aviation, they have been the kind of forerunners, and they have paved the way for women to enter the space program as astronauts. And we all know now that thousands of women were involved in the Apollo program as well as mathematicians, as engineers. And many of these women actually they worked very quietly and very efficiently, but mostly behind the scenes. And very few came into the limelight. Of course, as the program matured, the situation changed to a certain extent, and there have been several women in leadership roles. And in the current era, with all the private players, the situation is definitely even better. So that's really very encouraging to see. Now, if you come back to our own program, if you look at the Indian space program, we all know where we were initially. We had no rockets, we had no satellites, we had no launching stations, nothing. But from there, now we have come to a place where we have the end-to-end expertise in design, realization, testing of all the space systems, launching, and management of all the space assets. And women have played a key role in this saga of success across centers. However, the outreach part of this has not been very much till recently, when one iconic photograph received very wide attention. I'm sure all of us know which photograph we are referring to. That is of our women engineers and scientists joyfully celebrating the success of the Mars Orbiter mission. And this generated tremendous public interest. In fact, it continues to generate interest, and more so because of the film which followed this photo. But again, this is just the tip of the iceberg as far as the contributions of women in the space activities are concerned. We know, personally, I myself know, we have many women in space mission design, in the launch vehicle and spacecraft design, testing, then the quality aspects, and integration, checkout. Of course, many of your IIT alumni are also there now. And the launching, the space applications, space assets management, as well as R&D. So this is something which we have been contributing all along, and I personally have had the good fortune to be involved in the design and development of all the current ISRO launch vehicles. Now, while overall, if you are looking at the strength of the women engineers, it is around 16% in ISRO. But in my area, that is the guidance, navigation and control area, this proportion is much higher. So it is in fact more than 30%. And I am also very proud to say that almost equal number of girls and boys from my own old team, they have become leaders in their own right. Actually, what this shows is that one of the reasons for the less number of women leaders, which is very widely talked about, is that there are less women in the pool to start with. Because in our case, we had more women, and of course, the environment is very conducive. It's a gender neutral organization. And if you want to grow, you can. So that growth has been there also. I'm watching, and I've been very proud to see that this is happening. And I also see several budding leaders from your own IISTAA alumni who are working in diverse, challenging areas. I'm really looking forward to see all these leaders really grow. And on a personal note, I would also like to say that I was very happy to see Dr. Swati Mohan generating a lot of interest when she was successfully leading the NGC operations for the NASA Mars mission. Now coming to the human space mission. So here there is, in fact, the human element that becomes very important, which means not just the crew as well as the supporting ground team. So these systems or these elements are in fact as important to mission success as the technological elements. And our own, India's own human space program has generated tremendous national interest, not to mention international interest. And so many young boys and girls have actually come forward from all parts of the country, from the rural areas, even young children who want to participate in the space program, the human space program. Of course, again, their perception right now is that they want to get in as astronauts. Of course, as they understand more and more about the program, they will really want to contribute to other areas as well. And I'm sure that as the program matures, we are sure to see women astronauts as in diverse roles, as commanders, as pilots, but that has to evolve. The program itself has to mature, and then this definitely will happen. And right now, the role played by the women in the engineering system readiness, in the space medicine, in the crew support, and all other human-centric areas, that is really enormous. Now coming to another dimension, the environment in the country is now conducive, very conducive for entrepreneurship, space entrepreneurship. And there are already a few women entrepreneurs in the space domain who are making their mark. I've had contact with them. I'm really impressed with their vision and the kind of progress and their focus. So I'm sure that this tribe will continue to increase, and I'm again looking forward to seeing that happen. And I'm really looking forward to seeing our young women charting the future of spaceflight and leading from the front in all the related endeavors. I'm also awaiting today's lively panel discussion. Thank you so much for having me here. Thank you. Bye.
Thank you so much, ma'am, for your insightful and encouraging words. We have the great privilege of having Shri.S Somanath, Secretary DOS and Chairman ISRO as our chief guest. Sir requires no introduction, for his multidisciplinary expertise and his multifaceted personality have a legendary status. In his capacity as chairperson, IIST Governing Council, and as a former director of IIST, Sir has been a constant source of support and encouragement for all alumni activities. Sir, we are truly humbled by your presence. I now request Somanath sir to kindly address the audience.
Thank you, Ankita. Am I audible?
Yes, sir, you are.
Okay. Good. Thank you so much for allowing me to join this panel of being part of your celebration in a way that you are celebrating the International Women's Day in IIST through this panel discussion, which is a very relevant topic. Let me say once again that I'm really honored to be amongst the panelists who are going to discuss their own views on this topic. Dr. Lalithambika just now gave a very lucid presentation on what does it mean to people in space sector, not only ISRO but all across the country in space sector. I hope, I wish her desires and wishes to happen in days to come. As far as IIST is concerned, and I had the fortune to be linked to IIST in various ways, finally being the director also for a very short period of time. That gave me very good exposure to the way Indian Institute of Space Science and Technology work and also contribute in creating the required human capacity for the space sector. And now it's not only going to be for ISRO, but also going for the entire space sector of this country and the world. And there itself, I saw women do play a very important role in the whole of the faculty in IIST as well as our students. In fact, the percentage of them are not very high in IIST. They have not reached something like 50%. Maybe that's something which I look for in IIST to happen both in faculty as well as in student ratios. But the intake in this sector has been low overall, not only for IIST, but if you really look at in terms of higher learning, areas of higher learning, that their percentage of entry itself is low. But this is something that we need to address in the long term. If you are to really bring in more people into this domain or space sector, at the entry point itself, there has to be a reasonably high percentage. We would have seen that, say, if you really look at the school education system in my state, we see the women participation in that is very high. If you look at the teachers in primary schools, teachers in secondary schools, I see the percentage of women teachers are actually much more than the other half. Why it happened is because there is a natural talent and interest shown by them, and all the management also understand that the women teachers are more patient enough to handle these type of situations. But it's not the case in higher learning. Institutions of higher learning, where it comes to science, engineering, technology, etc. I have been seeing that in 2 institutes which I know, Indian Institute of Science as well as Indian Institute of Technology, Chennai, both are having very less percentage of women faculty. no, this is one indicator that the route to this higher positions and career is actually very tough. So this is something that we need to address in the days to come. How children can be, helped to take up careers and especially to spend longer years of time in learning, studying, and then taking up careers in this is a socially difficult proposition now, and this is something which need to be addressed and encouraged from families and from societies. So this is the first thing. Second is when they come to career, they also face enormous challenges, let it be in space sector, aerospace sector, but in other areas as well. The challenges are plenty. Being competitive in an environment where there are merit matters, it always is difficult thing because of the specific nature of the work of women, and the connection to the family life is very strong. I think this is again something that we need to address and still make some significant progress, and this can be achieved only when organizations understand this specific issue faced by them, and then create a flexible timing for work, flexible way in which they can contribute, rather than very rigid in various administrative frameworks which they work. And so until this happens, the real growth of women in the high technology area and areas where management challenges are much higher cannot be accomplished. So this is second area where the focus should be there. Of course, when you talk about our organization, ISRO, where I represent, or IIST also being part of, as Lalithambika said, there is a reasonable amount of occasions for women to grow and flourish. But I also understand, like every other institution, there are challenges. Let us not assume that it is all very fine everywhere. The approach to look at merit and also performance, many times I have seen that it is actually marred by the issues of their personal attention and contribution that are required elsewhere, which also creates sufficient amount of problems for them. But of course, people like Lalithambika has been successful in steering through those difficulties and show their mark, and many other women as well. But I know there are many more younger people who find it much more difficult to show up their merit in amongst other male colleagues. So this is something which is a very difficult issue, and this cannot be handled by them alone. It can be handled only by their colleagues, their co-workers, their immediate bosses. Unless they organize themselves to handle this, the improvement cannot happen. It's not because that they are having their intelligence or capability to do work or managerial abilities are poor. I don't think so. It is not at all there. They themselves accept a situation that it is okay to be like this. So this is also a social issue which is causing a little bit of problem in the growth of women leadership in this area. Of course, I will look for the talks by other eminent panelists who are here. In fact, I know all of them. In ISRO, Dr. Dona Mathew as well as Srimati Smith are well known to me. But the most important thing is I look forward to the talks by Wing Commander Kamaljeet Kaur from IAF, as well as Group Captain Mona Dahiya from IAF, for their insights and views on the type of problems or issues they face in their domain. It's entirely different, probably none of us are aware of what they're really going through, they're facing. So my salutations to you for accomplishing as much as they went through in their life and struggles to become noted, to be noted by us, our alumni in IIST, for them to be brought here to be amongst us. Thank you so much, and wish you all the very best in this panel. And thank you once again for giving me this opportunity in this panel discussion. Thank you.
Thank you, sir. Your words and presence are a great source of encouragement to all of us, especially here at IIST Alumni Association. We extend our gratitude to you for making time for us on such a short notice. Thank you. We are also privileged to have the best wishes of Dr. D. Sam Dayal Dev, Director IISU and Director IIST. Sir is well known for his role in the development of inertial systems that fly aboard all ISRO missions. In his role as Director IIST, he has been a constant support to the alumni, helping us build a synergistic relationship with our alma mater. We now have a pre-recorded message from him since he couldn't be here due to some other commitments. Amol?
Amog, we can't hear the audio. Can you share with the audio?
Amog, you might have to unmute the account.
Yeah, very good morning to all of you. I am extremely happy to know that IIST Alumni Association is planning this panel discussion on a very interesting topic. Unfortunately, due to my personal preoccupation, I could not attend live. However, that's why I am just giving a message to all of you. I am really happy to note that Dr. Lalithambika, my friend and a colleague, as well as we all belong to the space generation, who are currently the leadership of ISRO also is with the space generation group of people. And this topic is all the more very interesting because the current trend in whatever this year I would say the current topic of Women's Day was the removing the bias. So especially with respect to the high and untread areas of like being women in the being an astronaut, etc. I think that what sort of bias it has inherently, as well as what it can be really removed. And there definitely you need to really understand the pros and cons of space travel. At this point, that I'm really happy that Wing Commander Kamaljeet Kaur of IAF and the Group Captain Mona Dahiya of Doctor in Aerospace Medicine IAF are also present, apart from our dear colleagues Dr. Dona Mathew and Srimati Smith. So definitely the various aspects of this space travel by women can be explored, because there is certain health conditions which can be common to the human beings and more specific to the women. So therefore, definitely this would be a very interesting topic. As far as my view is concerned, see, these women usually are their perseverance is really high, or endurance is high, and at time of difficult times, women take decisions better than men. I think this is my personal opinion. Whereas women hesitate to take decisions, normal course. But at when they are stressed out, between men and women, I feel women take decisions very fast. So therefore, in critical operation in human space flight, definitely women can play a very, very crucial and decisive role. This, you are now all know about the Vyomitra, the half humanoid that is being planned for the first unmanned mission, which we need to really develop as an astronaut, as a humanoid, as an astronaut, which can really make a difference in the human space, long duration human space flights. There, when we conceived the idea of humanoid to travel in space, it is very obvious, it sounds very naturally that we decided for a women, or like Vyomitra. It came very naturally to us. Then later, when pressmen were asking about how you chose, etc., then only we thought very seriously, because the type of challenge, and as a person who can take decisions, that is why that an intelligent humanoid, we thought robot, it should be a woman. So that's a thinking. I think so that there in this area, at least, I think men do not have any much bias against women. Therefore, I think I wish all the very best for a very sound technical discussion, so that a future course of action with respect to the women, how some of the drawbacks can be overcome, etc. all those things can be discussed, and this is a very interesting topic. And really, I compliment the IIST Alumni Association, and in particular, Madam Surabhi, on organizing as well as inviting me for this discussion today. Thank you. Jai Hind.
We convey our thanks to Sir for his message. We also thank all the other dignitaries from ISRO and the Indian Air Force for their gracious presence. We now begin with the much awaited panel discussion. I now request Surbhi Bhagotia, President of the ISTAA Alumni Association, to take over as the moderator for the session. Surbhi.
Thank you, Ankita. At this point, I would also like to acknowledge that this was a teamwork with the core team of Ankita, who is the Joint Secretary. We have in the core team Prachi, she is the President of the Ahmedabad chapter of the ISTAA Alumni Association. And we also have Lakshmi, who is the executive body member of the Bangalore chapter. Now, we will move on to the panel discussion. But before that, on behalf of the ISTAA Alumni Association, I would like to welcome all the esteemed panelists for the panel discussion on the topic Women and Spaceflight, Charting the Future. In order to pave the way for the future, it's paramount to have a vision and to understand that where we stand and what we need to do in order to move forward. To give us a better understanding, especially from an Indian perspective, we have with us 4 distinguished panelists from diverse fields. The sequence of the panelists is decided in a way by which we can cover various aspects of an actual space flight. We have a pilot from the Indian Air Force who can give us an insight about the kind of training one is subjected to on ground for atmospheric flight, which is a step prior to space flight. On the other hand, to understand the challenges during the ascent of the launch vehicle through the atmosphere, we have with us a scientist from ISRO working on launch vehicle health management systems. We also have a doctor and an expert in aerospace medicine who will talk about the physiological changes that occur during spaceflight. And in the end, we will be listening to another scientist from ISRO who works on materials and technologies that enable a safe re-entry of the crew module, among other things. So let me begin with the opening remarks by Wing Commander Kamaljeet Kaur. I would like Amok to present the slide of the biodata of ma'am. Wing Commander Kamaljeet Kaur, she is an Indian Air Force pilot flying transport aircraft commissioned in 2006 with about 3,000 hours of flying experience. She was a part of the first ever all-woman crew parallel taxi track. This is something that I came to know just a few days back. What does this mean? This parallel taxi track landing and takeoff operations are a challenging task as the crew is required to land and take off from the taxi track, which is considerably smaller in width than a usual runway. And it has a proximity to obstructions as compared to the main runway where we land and take off. There is no scope for any errors during the most critical phases of flight, which is landing and takeoff. So she has an experience of flying various types of aircrafts, including Tiger Moth, and she is the only woman pilot in Indian Air Force qualified in microlight aircraft. We welcome you, ma'am, for your opening remarks.
A very good morning to all the respected and experienced guests and all associated with IISTAA Alumni Association. And I thank you very much to have me here and giving me opportunity to listen to the varied experience in the space flight and space sciences. So with this, I am Wing Commander Kamaljeet Kaur, a transport pilot from Indian Air Force. And as covered by Ms. Surbhi, I have 16 years of service. I have served at different bases. I have flown all across the country during my tenure in Indian Air Force. And I've been a transport pilot. If you know, the transport fleet in Indian Air Force is basically engaged in a routine task of carrying the combat equipment, men and material. They involve in hill flying, mountainous flying, oceanic flying, and majorly you would have seen the transport aircraft engaged in relief operations, COVID operations, and national disaster emergency evacuation operations. So in these operations, I have also some amount of experience, and during all my tenure in Indian Air Force, I have a flying experience of 3,000 hours. I have flown different kind of aircraft. During my training, I had flown HPT-32, thereafter Dornier aircraft, then a workforce of Indian Air Force, which is AN-32 aircraft, and finally microlight. Presently, I am flying both the aircrafts microlight as well as AN-32 aircraft. I am fully operational and I have operated mostly AN-32 aircraft. And at present, I am married to an Indian Air Force. I have an officer and I have 2 kids. I have a satisfied career and rather very interesting career, which gives me an opportunity to exploit all kind of military flying, which a commercial pilot would not have ever experienced. And because of my experience, presently I am handling the aerospace safety environment of a premier flying base. Today I am appointed as a Station Aerospace Safety and Inspection Officer of that base. If we talk about gender inequality in Indian Air Force, personally, I would like to share that throughout my experience of almost 16 years of service in Indian Air Force, I have never come across the gender inequality or bias, gender bias in Indian Air Force. During the career progression, different kind of missions, different exercises, there are some qualifying requirements. And if you have the capability and skill, you will qualify for that. And believe you me, either a male officer or women officers, we both are given equal opportunities to don the skills nicely over the aircraft and build up the capability to get selected for whichever the opportunities come. And if we talk about women in different sectors, today there are women officers in all streams, especially if we talk about flying. Indian Air Force has inducted fighter pilots from 2016 onwards. And today we have almost more than 10 female fighter pilots. And towards this space mission, of course, Indian Air Force has a different mission. However, contribution towards the space mission, the test pilots and the pilots which are being selected for these missions, the selection procedure was for the pilots who have been experienced. However, women pilots are just inducted. They have an experience of only 6 to 7 years in fighter stream, but they are being inducted on all the platforms which are available in fighter stream, be it starting from MiG-21, Sukhoi, Rafales. Women officers are everywhere, and there is no gender bias. They are given equal opportunities, equal kind of environment is provided. However, there are few physiological conditions which we women officers face, and that becomes at times a constraint. Like during their lifespan, they have to go through a medical situation wherein they are not able to do their primary task for few years when they are raising up their child. So at that time, they might miss out on their prime task. However, nevertheless, the opportunities and the platforms which are given to women officers whenever possible are always given by Indian Air Force. And if we talk about the military now, the induction in National Defense Academy and military schools have also just started. So I feel that for the women, to empower the women in different walks of life, initial women have already broken the glass ceiling. Now, to sustain the women in all all such operations, and what even United Nations is also pressing on, that women should be representing in all the sectors. We need to focus on the foundation, especially for the far-flung areas where maybe women representation or girl-child representation is less. However, if I am representing today as IAS, IAS has given all the opportunities in all streams. Women officers are already there, and few streams like fighters, it is recently inducted. They will build up the experience. They will become test pilots, and definitely they will be on the space mission one day. With that, I thank you all. Jai Hind.
Thank you so much, ma'am, with giving us such a hope. And also in the coming years, we would really wish that to happen. The next in line is Srimati Smith KS, who is the Deputy Project Director of Integrated Vehicle Health Management System of the prestigious Gaganyaan project, which aims to fly humans to space from the Indian soil. In her career of 15 years in ISRO, she has been involved in the design and development of various systems for ISRO missions like PSLV, GSLV, Chandrayaan-1 mission, RLV, and Human Spaceflight Program. She has published several papers in national and international conferences. She holds a patent on the ultra-high frequency receiver used in the RF communication link for the Moon Impact Probe. We welcome you, ma'am.
Thank you, Surabhi. Our Honorable Chairman Secretary DOS, former Director DHSP, eminent panelist and participant, a happy morning to all. So I am really glad to be part of this event conducted by IISTAA Alumni Association, rightly chosen the topic Women and Spaceflight. So I am today here as I am part of the human spaceflight mission of ISRO, the Gaganyaan. I had an opportunity to work in that particular project. Like everyone, irrespective of men or women, the entire human is fascinated towards the space. So that's why women, right from Valentine till now, there have been more than 75 women in space. So gone to space and contributed towards various sectors like genetics, nutrients, tissue culture, so and so. That's why we are able to proceed with that. So I think women and men play a complementary role rather than women complaining about the things what they are not getting. We should work in hand with the men and produce fruitful things for the nation. So rather than telling about looking into the concept of looking the thorns on the rose plants, we can tell that even the thorny bushes are producing the roses. So I think we should go ahead with our abilities and capabilities to exhibit our talents and come in par with the women rather than trying to beat them up. We should work in par with the women rather than complaining about them, or we should support them, or we should work in shoulder to shoulder. That's what we should aim for it, so that we will produce something useful for our nation and country. As our wing commander was telling, that during the induction of our astronauts, like when we are taking up the astronauts for our mission, there were no test pilots, women test pilots. That's why we have gone for our men test pilots. So in the near future, as ma'am has already told, like there will be test pilots, women test pilots also. So that I hope in near future we will be having women crew in our prestigious Gaganyaan project too. And thank you, Surabhi, and thank you for calling me for this event. Thank you, everyone.
Thank you, ma'am. Thank you for sharing your insight on this topic. Now we would be moving on to Group Captain Mona Dahiya. She is currently heading a team of 7 doctors as the Senior Medical Officer of a premier flying base. She is the first lady to be part of a foreign exercise nominated as the contingent doctor in 2008 to 4-nation flying exercise Red Flag in the USA. She is the first lady to serve as the Director of Aerospace Medicine at Air Headquarters, and she's the secretary, the first female secretary of the Indian Society of Aerospace Medicine. She was head of the Department of Acceleration Physiology at IAM. We welcome you, ma'am, to share your insights on the topic.
Ma'am, you are mute.
Ma'am, you are muted. Can you unmute?
I'm sorry. I'll start again. Thank you, Surabhi, and I'm really glad to be a part of this eminent panel today, discussing the future of women in space flight. As Surabhi has already mentioned, I am a serving Indian Air Force officer, a doctor, having specialized in aerospace medicine, and I have about 27 years of service, having served all over the Air Force. And I'm a specialist in aerospace medicine. And when I was doing my specialty is when I realized that the future of mankind lies in space exploration. And this is a field that has always fascinated me. And I have always tried to keep in touch with what is happening as far as integration of women in this premium field, or for that matter, even in aviation, and for women trying to break the glass ceilings across. And in fact, one of the research projects that I did do during my specialization, my MD, was on the gender differences in vigilance functions and reaction times. And of course, what we had found in that course of that study was that there was no difference. Subsequently, studies have been done in my department, which I'd headed, that is the Department of Acceleration Physiology at IAM, about any physiological differences as far as the G tolerance for women is concerned, and no significant differences were found. So it is very apparent from all the research that has gone in the past several decades of space exploration and space flights that it is there would be some bit of physiological differences between men and women, which can be compensated for by training. It is just that the amount of data that we have today as far as women in spaceflight is concerned is not very much. It is just about 15% of all the astronauts till date have been women. So, as I said, the data, there are some limitations as far as the data are concerned, but a lot of space simulation studies get done on ground. And in fact, there's some studies to indicate that for a long-term space mission, like going to the Mars, which will be about 3 years in duration, women might actually fare better as compared to men. So, as I said, as far as physiologically it is concerned, the differences aren't too many. Training can compensate for that. It is just that we should be ready to integrate more and more women into the space flight. I would like to kind of walk everybody through some of the physiological changes that do occur in the course of a space flight. Basically, gravity plays a lot of role in orienting us to our environment, and also it is responsible for a lot of physiological parameters that are there on the Earth. The moment you remove gravity and a person goes into a zero gravity or a low gravity environment, that would be true for a lunar mission or a Mars mission, a lot of changes start happening. Now, this would be basically, it starts with the fluid shift that occurs from the lower limbs, and the fluid that normally pools into our lower limbs because of gravity starts shifting towards the center of the body. And thereafter, it starts causing a lot of changes as far as our heart function is concerned, the neurological function that is concerned, our ability to orient, the vestibular system that is concerned, there are changes in the eyes, and so on and so forth. And of course, there are changes as far as the muscle strength is concerned, the bone strength is concerned. So most of the changes are reversible, but there are some changes which could perhaps be permanent in nature, which is something like loss of bone mass. That notwithstanding, lot of studies in the last 60 to 70 years of spaceflight have come in. We are getting better and better to put in countermeasures so that a person who goes into space doesn't have any long-lasting effects. Some sort of compensatory exercises are there. The subsequent, during the course of the panel discussion, we would discuss about how women physiologically differ, and what women should be worried about, or what kind of extra precautions we can take to put women into the space flight. As I would agree with what Kamaljeet said, the Indian Air Force is an absolutely gender-neutral organization. and all the opportunities that I have got in the past 27 years, and I see the other women getting all along, is tremendous. It is the ability of the women in the Air Force which is seen, and not their gender at all. So that is how you have women officers in all kinds of fields now. As she was mentioning, the last bastion has been broken, that is the fighter pilots. Now we have women fighter pilots. In fact, there is already a lady officer who's undergoing a flight test engineers course as well. And the day is not too far when we will see women test pilots as well. And thereafter, they will be participating in the human space flight. So I look forward to having a healthy discussion with everyone. Thank you.
Thank you, ma'am. We know it is a step-by-step process wherein now that women have been inducted in the fighter pilot stream, becoming test pilots, one day they will also be going to space. Also, I would like to mention that we will be going more into the details of the physiological changes in the question answer session. So let's move on to the final remarks by Dr. Donna Mathew. Dr. Donna Matthew heads the Polymer and Special Chemical Division at Vikram Sarabhai Space Center in Thiruvananthapuram. Earlier, she has served as the Deputy Project Director, Human Spaceflight Project, and Project Manager for Space Capsule Recovery Experiment. Currently, she is the Deputy Project Director in the Gaganyaan project. She has 22 patents, 60 publications, 5 books, and several awards to her credit. We welcome you, ma'am.
Thank you, Surabhi, for the kind introduction. Good morning, respected Chairman ISRO, Secretary DOS Somanath sir, Director IIST, Dr. Daya, Lalithambika Madam, esteemed panel members from Indian Air Force as well as from VSSC, Srimati Smith, and everyone gathered today. I feel honored and privileged to be a part of this function, and I thank the IISTAA Alumni Association for this opportunity. So let me talk about my motivation for joining ISRO. I had done my PhD in the Polymers and Special Chemicals Division of VSSC, and I have registered as a PhD candidate in the University of Kerala. So after completing my PhD on polymeric systems, I moved forward to the University of Bordeaux, France, for doing the postdoctoral studies, where I was doing some fundamental studies on polymerization techniques. It was actually an eye-opener for me. In the university, we had a lot of facilities. It was open to all, freely operated by all students. And at the same time, I also noticed that Indian students are not at all inferior to the foreign students. In fact, they are equal or better than the foreign students. So I was looking forward to come back to my own country and serve my country rather than working abroad, doing work for others. So that was the real motivation for me to come back to India. And actually, my research supervisors, Dr. K. Nainan and Dr. C.P. Raghunathan, they have supported me a lot and they have encouraged me. And all scientists who were present at that time also motivated me to come back and join ISRO. So I was very happy coming back, and it was in fact a transition for me from the field of fundamental research to applied research, which offered a lot of challenges. And in fact, it was really challenging and exciting to see the new products coming up, the team who is very vigilant and very active for working towards development of advanced materials for ISRO's current as well as future missions. So I was also very happy and lucky to be a part of such a dynamic team. And where we are starting on a very narrow platform and with very little database, it's all the more challenging and exciting. And failures are not very uncommon, but these setbacks help us to come back with more vigor and with more perfection. So in PCM entity also, we are working on several advanced materials, which is ranging from green materials, green propellants, specialty thermal protection systems, lightweight thermal protection systems, specialty coatings, adhesives, sealants, energy systems, etc. And for the Gaganyaan program also, our team is vigorously working on development of several advanced materials that satisfy the stringent aerospace applications for stringent aerospace standards to meet the human spaceflight requirements. So the requirement for advanced materials is ever on the increase. And I am very proud to say that ISRO is offering equal opportunities, ample opportunities to all those who are willing to do hard work without any gender bias. So in my career, I have never felt such a bias, and I was very happy and fortunate to have worked with such a wonderful team with a very good seniors and who could guide us and who could help us whenever we are in some difficult situations. So recently what I am feeling is that the government policies and the transparent systems are attracting more and more women into aerospace research field, and they are contributing very effectively in these areas. And this will definitely help us to build a scientific platform for a brighter future. So let me conclude quoting the words of the Assistant UN Secretary General. We must ensure that women's participation in innovation should not be an exception, but it should come as a norm. That's all. All the very best to all of you. Thank you very much.
Thank you so much, ma'am. Thank you for all the panelists for sharing their individual journeys and their perspective on the topic of today's discussion. With this, we end the formal remarks by panelists, and we will now move on to the discussion. Let's start with Kamaljeet, ma'am. Ma'am, if you can open your camera. Okay, so yeah. So, ma'am, we would like to ask you, what inspired you to pursue a career in the Indian Air Force, and how was the selection process for you?
He said regarding the inspirations, since my childhood, it was in the bloodline. My grandfather was in army. Thereafter, my father was in army. So donning the uniform and serving military came to me naturally, and it was inherited. However, coming to Indian Air Force, it happened to me when I was in while I was pursuing my graduation. Then one of the seniors, he told me about the pilot branch. The opening was available that time, and that time I filled up the form and I went through the selection procedure, and I was lucky enough to be part of this organization. So, and regarding the selection procedure, because since we are discussing with respect to the women and everything, so since then also when I joined, now I have an experience, and now also we are discussing women in Air Force. That time also I never felt in the selection itself and while my training there was any difference between a male cadet or a female cadet. All the standards, everything was equal. Maybe as covered by Group Captain Daya, that physiological some conditions are different for which we are trained better. However, if we talk about the pilot stream, every QR, everything, even the training, nothing was different. We all faced equal kind of, we all undertaken equal kind of ground training, thereafter flying training, all the standards, everything was same for a male officer as well as a female officer.
Okay,
yeah.
Thank you, ma'am. Ma'am, now this question is addressed to Mona, ma'am. IAF inducted its first batch of women fighter pilots very recently, ma'am. So, in your experience, what is the selection criteria for the fighter pilots?
The selection criteria for women fighter pilots, or are you talking about selection criteria for fighter pilots in general?
Ma'am, I'm not sure if it is different. If it is different, you can also tell about the women fighter pilots.
That's exactly what I wanted to highlight. Well, there is no difference. Whether it is the anthropometric standards that are expected, we must all remember that the aircraft that the Indian Air Force is using are designed for a 5th to the 95th percentile of male population. So now you have to select people who would fit into this the anthropometric parameters that are expected. So whether it is the selection criteria as far as the different reaches is concerned, or is the leg length that is concerned, it is identical. And what a person needs to go through as far as the selection procedure is, of course, there is a lot of psychological testing that is done to ensure that what we are looking for in a pilot and in an officer, those qualities are there. Thereafter, the basic intelligence that the person is subjected to, the ability to work as a team is focused upon greatly before induction. We're looking at team players. We do not want individually brilliant people. We want the people who work well in a team and who work well in stressful situations. So that kind of aspect is also seen before before they undergo a pilot battery of tests, which is the aptitude test. Basically, the psychomotor skills of the people are tested. And as I said, it's a test which goes through, it's a 5-day selection process, and a person has to pass the test every day to go on to the next day. And it's only at the end of the 5th day that the person gets selected and then goes through the medical. Now, the medical is an equally rigorous process, which will last for about 3 to 5 days. And we have what we call as A1, G1 standard. So the person should be fit for all kinds of duty anywhere in the world, whether it is in the air or on the ground. So a complete checkup would be done. So whether it is the audiological parameters or 6x6 vision, no underlying pathology of any kind, cardiac testing is done, ultrasounds would be done. And of course, more importantly, especially when we select pilots for that matter, we do not select, we do not select helicopter pilots or transport pilots, we only select pilots. So everybody would go through the same kind of standards in the process. The spinal checkup is entirely done. So a complete CT scan of the spine is done to see if there are any underlying spinal pathologies, because that could, over the period of the career or the time the person flies, conditions could aggravate. So as I said, the medical in itself would take about 3 to 4, even 5 days at times. And it's only then the person is able to join the Air Force as a pilot.
Okay, thank you, ma'am. We were curious, like I was personally curious to know what defines the anthropometric parameters? Like why do we have a particular hand length, leg length? Is it all defined by the kind of aircrafts we are flying?
Actually defined by the aircraft, because you're looking at clearances and reaches. Okay, so if somebody is sitting with a helmet, so you added about 2 to 3, 4, at times even 4 inches if there is a helmet mounted display. So the clearances from the top of the canopy should be absolutely there, so the person doesn't injure. If the person was to eject out of a fighter plane, then there is no injury. We're not adding any injury to the person, potential to survive that particular situation. And the other, as far as the leg length and the arm length is concerned, it is basically about reaches. So a person, while fully strapped up in an upright seat, is able to reach all the different switches placed at different places in the cockpit. So that is why we play so much of an emphasis on just basically it's 4 parameters we would be checking. It would, of course, we have the standing height, but the standing height is it's 162.5 centimeters, whether it is for males or females. But it is basically more about, of course, about military bearing. So we want people, of a military bearing, but it also gives you a good indication of the other reaches as well. So whether we are talking about leg length or the arm lengths. So once then we look at the sitting height, as I talked about, sitting height being basically canopy clearances, and the arm length as well as the leg length. So 4 basic parameters, and a person has to meet those criteria that is laid down, and only then is able to clear the medical.
Yes. I want to highlight here that all the fighter aircrafts that we are flying, most of them are coming from other countries. So the aircrafts are designed based on the anthropometric parameters of the people of that country. So if we start having designing and building aircrafts, fighter aircrafts in India more and more, probably it can be, the parameters can be brought towards Indian.
Yes, you actually put up a very pertinent point, Surabhi, because the LCA that we have designed actually has taken in the Indian population. So we have designed it for the 5th to the 95th of Indian population. Of course, anthropometrically, we've been buying, most of our aircraft are coming from the West. So, so whether it is America or Russia, they are much taller and much heftier than us. So obviously, we in the process, because we've selected aircraft from abroad, we have had to reject a whole lot of people, whether it is males or females, who would actually have made excellent pilots. But because they were not meeting these standards, we've had to reject. So here we are designing our own aircraft so that we are able to put more and more Indians into the field and make use of this wonderful pool of manpower that is available to us. So that is being taken care in the LCA project. I was briefly associated with it. I worked in IM for about 4 years, so different things we were working on for the LCA project as well. So I am aware of these issues, and it's been taken care of.
Very good to know, ma'am. So coming on to Smitha ma'am, ma'am, in a crewed mission, the safety of crew is paramount. How is the launch vehicle, which is designed for humans, which is named as the human-rated launch vehicle, how is it different from one which is designed for satellites?
Yes, Surabhi, you have rightly pointed out that in a manned mission, safety of the crew is paramount. So, so that's why we call the manned missions as safety critical, but the other missions which are intended to put the satellite into the orbits as mission critical. So, in order to considering the safety requirements in a manned mission, the crew safety comes as the important thing. Like we have to safely transport the crew and bring the crew back to Earth. For this purpose, what we have is we should have a highly reliable systems. How the reliability is being achieved is by providing extra redundancy as well as the margins. So how, for example, in avionics systems, if we consider, we are providing a redundancy of quadruple redundancy for the human rated launch vehicles. Whereas in the other missions, we are providing dual redundancy. Once in quadruple redundancy, what we are doing is, in case of the first failure, we will be continuing the mission with the all remaining 3 systems. In the event of the second failure, we will be doing the safing operation so that we can bring back the crew safely with the available 2 healthy systems. Whereas in the missions, like satellite missions, what we are doing, we are having 2 systems. In case of the first failure, we will be going ahead with the second so that we can put the satellite in the orbit. That is our intended function. And coming to that, how with this redundancy, how we have to know what are the failures coming. So we should have a launch vehicle health monitoring systems, looking for certain critical parameters and checking them with the predefined bounds or the models. And then if some of the parameters are crossing beyond a limit, then we will call for a necessary abort. We will raise a flag so that we can bring the crew safely to that. So now we have raised a flag. How we will bring the crew safe? We should have a crew escape system which is more reliable. And it has to act very fast. It has to, because we are passing through the atmospheric region where it is we are facing highly dynamic and transient conditions. Our crew escape system should act very fast, taking that it should have a acceleration, very high acceleration, which is of the order of 12 times, and it should act within very short duration, like 2 to 3 seconds. That's why we have a crew escape system where manned is there. These are not available for other missions where we put the satellites into the orbit. So these are the design, major differences between the manned as well as the other missions, satellite missions.
Can you give 1 or 2 examples of what kind of problems can happen during the ascent phase where this health monitoring system will alert us?
Yes, so let us take our atmospheric regime only, because that is the most crucial point where we have to travel. Facing the transient conditions and static and dynamic loads will be coming over there. And there our requirement is to, we have to move away from the launch vehicle as soon as possible detecting. So we can't look for all the parameters within the launch vehicle. That's why we have selected certain critical, because our launch vehicle health monitoring has to make a quick decision as well as when, and it should not it should be 1 order higher reliability than the other system, because it is going to make a self decision on its own based on the inputs what it are getting. So we are not looking on a single parameter. We will be putting our sensors again in quadruple redundancy. And also we will be looking for a corroborating measure. Say suppose when we take a chamber pressure, we are not just only looking for the chamber pressure from the sensors which are in quad. We are also adding another parameter, like because chamber pressure is directly related to the acceleration of the vehicle. We will be looking for that corroborating parameter as well before taking any decision. So again, the LVHM, we are providing a better reliability, operating in a fail operational, fail safe. That is, even under the 2 system failure, the 3rd system will also be able to provide a decision. So that way we are providing more reliability with respect to that. And when it is, and once we have detected, now the crew escape system has to act very fast. And that's why we have provided solid motors in the crew escape system, so that a different set of motors to operate in the, because we have to go up to 70 kilometers regime. Till then, crew escape system is necessary. That's why we have put low altitude motors, high altitude motors, and the pitch motor to move, provide sideward momentum, so that it is moving away from the ongoing launch vehicle, even the failing launch vehicle also. Similar design considerations are brought into the system so that we will be, at any cost, we won't be giving a false alarm or miss, and we will safely bring the crew back to them.
Okay. Thank you, ma'am. This was about the ascent phase, and now when we go to the orbit, so I would like to address this question to Donna, ma'am. Ma'am, in orbit, when the crew module is carrying the astronauts, what kind of temperatures are these crew modules subjected to? Also during the ascent and the orbit and re-entry, and how are these temperatures maintained inside the crew module?
Okay, if you are considering, am I audible? Yes.
Yes, ma'am.
When we are considering the thermal environment of the crew module, we have different types of thermal protections for the crew module. So external to the crew module, we have the thermal protection systems for the entire crew module area. And inside we have the thermal and humidity control systems inside the crew cabin, which will be controlling the temperature inside the crew module during ascent phase, as well as during on-orbit and re-entry time. So generally, there will be a pre-chilling for the crew module just before the launch. So the temperature will be something around 18 degrees Celsius. And after ascending to the required height, when the module is on orbit, the temperature range will be in the range of 23 to 26 degrees Celsius. It can vary from 20 to 26 degrees Celsius. And just before re-entry, there will be again another pre-chilling. The module will be cooled to 18 degrees Celsius, and by the time of touchdown, the temperature can vary from 18 degree to around 26 degrees Celsius. So the thermal control inside the crew cabin is mainly achieved by the thermal and humidity control systems, where we are having heat exchanges, and they will be expelling the heat that is generated by the humans inside the crew module, as well as the packages which will be generating heat on operation. So generally, the temperature will be ranging from 18 degree to 26 to 27 degree within the crew module during the ascent phase till touchdown.
Okay, ma'am. And also looking at the external surface of the crew module, since you are designing the thermal protection system, what are the external temperatures for which you have to design the TPS?
Yeah, so the external temperatures during re-entry, the maximum temperature will be faced by the TPS during re-entry, and that can be of the order of 1800 to 2000 degrees Celsius. So the TPS that we design should be efficient enough to block this temperature and limit the backwall temperature of the TPS to less than 150 degrees Celsius. So the temperatures of the order of 1800 degrees Celsius will be coming at the aft heat shield, where the maximum heat flux of the order of 216 watts per centimeter square will be experienced by the TPS. And there are other benign regions where the heat flux will be on a much lower level, like 50 watts per peak heat flux will be in the range of 50 watts per centimeter square, where we can have a TPS with a lower mechanical stability. Whereas wherever there is a high heat flux regions are coming, which is more demanding, we will have materials which are capable of withstanding higher temperature with sufficient mechanical integrity.
Okay, ma'am. Just a follow-up question. What kind of special materials are we using for this kind of reduction of temperature across?
Yeah, so the most popular type of thermal protection systems are ablatives, which on impingement by the high heat flux will be sacrificially decomposing. Then they will be evaporating, some material will be volatilizing, and that will be in turn bringing a cooling effect to the structure. And these ablative materials in this process will be protecting the layers beneath them, and that is how the materials are protecting the crew module as such from this high heat fluxes and the thermal environment. So there are other types of thermal protection systems also, but these ablatives itself are of different categories, which are having high density, low density, medium density, etc. And hybrid thermal protection systems, which will be encompassing inorganic materials as well as organic materials in combination with the specialty fibers and fillers, are generally used as thermal protection systems by all space agencies.
Okay, thank you, ma'am. Now the question is addressed to Smitha, ma'am. Ma'am, you talked about the launch vehicle health monitoring during the ascent phase of the launch vehicle, but are there any, can this type of monitoring be done during re-entry? Are there any systems which can help us during re-entry?
Yes, Ruby, our launch vehicle health monitoring system, we call it as actually integrated vehicle health monitoring system, and which is distributed across the launch vehicle systems as well as the crew module systems. After the ascent phase, during in the on-orbit phase, the orbital vehicle health monitoring system will be taking care. However, in the re-entry phase, because our re-entry is because we have to do the deboost operation as well. We can't do the deboost operation at any point of time. We have to see where we are going to land, because our ISRO mission we are planning for a sea landing. So we have to just wait for where the suitable location where we can safely land our crew. Here, instead of doing an abort operation during the re-entry, here we will be reconfiguring the system. We have 3 independent systems. If suppose one system has failed, we will be doing the fault detection continuously. If one system has failed, we will move to the second system. And even we will reconfigure the third system so that with a single chain also we will be able to come down. As such, there is no abort during the re-entry, but we will be doing the fault detection and coming back, so that we will be taking care of the crew safety. That's what we have planned with respect to the re-entry. But more stringent, more demanding conditions are required in the ascent phase. On orbit phase also, we can just wait for the systems so that we can safely land the place where we want to do. We can wait and do it, but not in the case of the ascent.
Okay. So I would like to address this next question to Mona ma'am, because since we are talking about re-entry and getting back to Earth from space, ma'am, what kind of G levels can the humans tolerate while we are traveling to space, and is it difficult to readapt to the Earth's gravity after coming back?
About 10 to 12 G can be tolerated, and it will actually depend upon the axis in which the acceleration forces are being, a person is being subjected to. So if it is GZ, the tolerances are much lesser. So about anything about 10 to 12 is comfortable. But during the launch process, the astronauts are not sitting upright. Their seats get tilted because our toleration in the GX directions are higher. So there, I think anywhere about 14 to 16 GX is comfortable enough for a person. Can you repeat the second part of your question, please, Surbi?
Ma'am, how do we readapt after coming back from space?
Okay, so we would, to understand what happens during readaptation, we would understand, I'll go back to what changes happen first. So one of the first things that the moment a person goes into space is this lack of gravity causing the fluid from the peripheral part of basically from the legs, it starts getting pushed into the central circulation. So because of that, immediately after re-entry or 6 hours thereafter, the faces of the astronauts start looking a little puffy. They start experiencing things like nasal congestion. There is also an increase in the intraocular pressure. In fact, my MD thesis was on measuring intraocular pressure changes, and we'd done this in the dry flotation tank, and where we had found significant changes which happened in the initial part of the process, but thereafter it starts settling down. So the intraocular pressure starts changing. There are changes in the visual acuity that occur. Also, because of these changes in the fluid, there are neurocognitive changes. There are changes in our vestibular system, our ability to orient, because gravity plays a very, very important role as far as how we are able to adapt about what is up and what is down. All references go off in space, so there is nothing to tell you. In the process, the astronauts experience what is called as the space adaptation syndrome. They basically have issues with it's a space motion sickness which starts happening, and they have to go through this whole adaptation process. Initially, they would experience nausea and vomiting. There are changes as far as the heart rate is concerned, and of course, if a person was to stay for a sustained period in the space environment, the muscle deconditioning starts happening. The cardiac muscle also deconditions. We're talking also about the skeletal muscles. And also, as far as the deconditioning, or rather the demineralization of the bone starts happening. Basically, about 1% of calcium from the bone starts coming into the circulation every month, and this finally starts going out through the urine. So there are changes which, depending on the duration of the stay, could be persist or be harmful in the long run, or perhaps they settle down. So once a person lands back onto the earth, now the orientation from 0G the person has to start orienting back to 1G environment. Now this is where the whatever we were talking about, the muscle decompensation that has occurred, the muscle atrophy that has occurred, that causes a problem. The vestibular system causes a problem, and people, I'm sure we've always seen these visuals where the astronauts, once they land back, they are not, they don't walk on their own. They are kind of lifted and they're given some time to orient themselves back. Basically, because people tend to experience orthostatic hypertension, which is once they stand, they start feeling dizzy, or sometimes people might fall, the astronauts might just fall down. So the adaptation process, as far as the fluid changes that are concerned, it takes a couple of days. But as far as the muscle loss and the calcium loss it takes much longer than that to recover. So adaptation would take time, and it also depends on how much. So if a person has spent, say, 500 odd days in space, it's going to take that much longer to readapt to the gravity situation.
Okay, ma'am. And earlier you talked about women might fare better in long duration missions. So, ma'am, in what ways do you say that, or have there been any studies related to that done?
Why I said so was, say, if it was a 3-year mission, say a mission to Mars is being planned. So a lot of other things will have to go in. So it would be things like food will have to be carried, oxygen or oxygen generation systems will have to be carried, medicines will have to be carried. So women, because of their short stature, so the amount of food that will be consumed will be lesser. That is the first this thing. The amount of carbon dioxide that is generated, or the amount of oxygen that is used up will be lesser, so they'll fare better in that terms. Women also are better as far as their ability to cope with stress is concerned. Of course, the cardiac decompensation will perhaps be lesser in women, although once women land back onto the earth, they experience more dizziness. But as far as these factors like lesser surface area, so lesser food requirements and better stress coping abilities would make perhaps if we have to send a manned mission to Mars, and all women manned mission to Mars could actually save a lot of payload. So it would work out more economical and perhaps better in that sense.
Okay, and on the other hand, we will also be equally working towards carrying heavier payloads so that we can carry all humans to space. Now, the next question is addressed to Kamaljeet Kaur, ma'am. Ma'am, Indian astronauts would most likely be called Vyomanauts or Gaganauts. What are your thoughts on inducting women Vyomanauts in the Indian human spaceflight program?
Inducting women in women space flight program, Womenauts, as I covered, IAF has already taken its first step, because if we start, initially when women were inducted, they were inducted in medical sciences branch, medical branch. Okay, it took a lot of time, and in 90s only they started the women in flying branch. Okay, and the flying branch, when they started, the women officers were only for the short service commission. Very recently, they have now started taking women officer as a permanent commission officers. So, because to undertake this kind of flight, space flight, it should have a foundation. For the foundation, the step has already been taken. Now it will get seasoned, it will build up an experience, and women officers will become, now as they are becoming fighter pilots, then they'll become test pilots, and of course, they will be qualifying for the QRs for getting into space. So the IAF has already taken all these steps. That's what recently as I am saying, the women permanent officers, because by the time in their training, when they are trained in the specific school, initially they are trained for the basic flying skills, be it helicopters, fighters or transports. Once they complete their basic flying, then they get into a specific platform. Okay, so specific aircraft, then they continue their building up their experience on day flying, night flying, all kind of operations that specific aircraft can do, which takes at least initial around 10 years of their service flying. Now, when they are capable of, they have already had some kind of experience, they might upgrade to advanced aircraft. Okay, so this kind of basic structure or basic build-up is required to have women in the space flight. So this we have already taken a step into. So in future, definitely we'll see all these changes and women in space flight.
Yes, ma'am. And as you said, there have been so many women inducted. So, ma'am, based on what you have learned from your colleagues in the IAF, like which kind of training is undertaken to help them deal with high stress situations with very small response times?
See, ma'am, in our training, like the kind of exercises regularly conducted, the kind of flying missions are being undertaken. There are very flying itself is a very kind of job where quick reaction has to be done. Okay, any kind of emergency, any kind of situation can arrive at any time, so you have to react in time and with the correct decision you should take, because it is in seconds only. So if we talk about the mission, generally at the regular basis, all these kind of exercises are undertaken so that people build up. Basically, they start with the groundwork. Kind of suppose there is a night mission. So in night mission, all kind of the factors which come into play for night operations will be covered thoroughly, discussed. Thereafter, the training sorties will be undertaken, and once the person qualifies in those training sorties, then night operations will be undertaken by that qualified person, and then night mission, night exercises will be taken up with the sister services, or abroad exercises with other countries will be taken up.
Okay, ma'am. Ma'am, Donna, ma'am, would you like to add to this question about the training that is undertaken from a doctor's perspective to help the astronauts or the pilots deal with the high stress situations? Mona, ma'am.
Surabhi, can you repeat the question, please?
Yes, ma'am. I was asking from a doctor's perspective, would you like to add on to what kind of training is undertaken to help deal with the high stress situations and small response times?
There is a lot of training that is done on simulators. So whether it is the flying simulators or even the simulators that we have at the Institute of Aerospace Medicine, whether it's the high G simulator or the high altitude simulator, the explosive decompression chamber, the vibration stress, and the other kind of training, and what is done all across the Air Force, and what Kamaljeet was also mentioning, is that training is repeated. It's never that you train and then you just let go. So at every stage of the career, a person is made to undergo both physiological stresses as well as the flying related stresses, so that a person is able to better cope with all the various kind of challenges that are thrown to the person in the course of the service environment.
Okay, thank you, ma'am. Now coming to Donna, ma'am. Ma'am, during orbital missions, not only do we need to protect the crew from the temperatures that are faced, there are also dangers of micrometeoroids and orbital debris and other space radiation. So how do we protect the crew during such situations, ma'am? Donna, ma'am?
Yeah, as you told correctly, there will be several threats faced by the astronauts during the on-orbit conditions. In addition to the thermal fluctuations, the temperature fluctuations, there will be very harmful space radiations, which are highly harmful, and the crew is to be protected against such radiation. So there are specialty materials that will provide protection against radiation. So one such example is high density polyethylene, which will be used inside the crew cabin as well as in between the thermal protection, just beneath the thermal protection system, to prevent the space radiation, harmful cosmic and galactic radiations from reaching the crew cabin. So that is one material, high density polyethylene, that is giving ample protection against the space radiations. And in addition to this, there is a big threat from the micrometeoroids. So different sizes, meteoroids of different sizes are there. So we have to effectively protect the crew module against the impact from the micrometeoroids. So if the size of the micrometeoroids are large enough for an orbital maneuvering, that will be okay. But when the sizes are coming down like less than 10 centimeter, there should be a protection that is existing, inbuilt protection existing in the crew module design itself. So generally Whipple shields are used, which are like metallic sheets which will be separated by a distance. So this will be effectively preventing the micrometeoroids from entering into the crew cabin. But nevertheless, it is likely to happen, but we should have efficient impact resistant systems. All materials are preferably impact resistant to protect the crew module against the micrometeoroid impact.
Also, ma'am, during recovery operations, once the crew module has come back from space and it falls or splashes down into the sea, there are safety issues not only for the crew which is sitting inside, but also for the recovery personnel who are going to go and recover the astronauts. So in which ways do we ensure the safety of the recovery personnel? Are there any systems that you have been working on for that?
Yes, that's a very important factor that we have to address during the recovery operations. So in fact, there are two things that we have to take care of. First is that when the crew module is floating in the sea, it should be spotted at the earliest, for which we will be using sea marker dyes, fluorescence dyes that will be spreading instantaneously over a few kilometers so that it can be spotted from a distance at the earliest. And for the divers to approach the crew module, there will be the left propellants or went out propellants in contaminating the seawater. So that these are very harmful materials. So the divers should be protected from these harmful materials. So when the diver should approach the capsule will be determined by a special device which will be continuously monitoring the concentration of the vented out propellant in the seawater. So when the propellant level is below the threshold levels, then we get a signal the divers can approach the capsule. So this is how the recovery operations are planned a priori.
Okay. And Smitha ma'am, from your point of view, are there other technicalities involved in crew recovery? What kinds of avionic systems are used for the recovery?
Yes, Surabhi, as Dona ma'am is pointing out, in addition to the dye marker, we are using a search and rescue beacon, which uses, which will be sending a pulsed signals to the satellite signals as well as to show the locations, because basically a pulse signal will be sent to a Cosmos satellite and indicating the presence where it is, and it will be using along with the GPS as well as NAVIC data to find the location of the signal. In addition to that, because if it is a cloudy or if it is a dark over there, we should know the some lighting system is also used to a flashlight will be glowing to know the presence of the crew module, so that at the earliest within 1 hour we should recover the systems, the crew, and we have to bring back them. And then as told, like dye marker systems. And in addition to that, then the crew recovery procedures like helicopter ships will be there within some few kilometers ready with the aids to take the crew safely, and medical procedures will be there. Those are the systems planned for the recovery procedures. And in addition to that, before coming down, like once we splash down, we will be cutting the power, because it should not cause like the battery or the power should not cause further short. We will be releasing the parachutes from the main parachute, final parachute. When touchdown is in, we should be releasing the parachute, otherwise it will drag the crew module. So such safety procedures are being adopted before the recovery procedures are being done. And we will move the ship, and the crew recovery team will move at the earliest and bring back the crew safe to the.
I would like to highlight here that ISRO during these recovery processes, ISRO not only works alone. There are many agencies from the armed forces as well. For example, the Indian Coast Guard's help is taken for the recovery operations.
And
Yeah.
And I have heard that you were part of that system once, and so it's very glad to know that.
Yes,
Yeah,
ma'am. I got an opportunity to go in the ship during the airdrop test, so I could see how the Indian Coast Guard works and recovers the crew module.
And it was a very pleasant moment, right?
Yes, ma'am. It was very good, and I think it was a lifetime experience. But
definitely, and you could stay one night at the ship also. Right.
Yes, ma'am. We all stayed there. Yes, ma'am. The recovery team. So. Along with that, we would also like to mention that there is Indian Air Force help, which we take during all the kinds of tests. For example, the Air Force helicopters are used for taking the crew module to a particular height and drop into the sea and then do the recovery trials. Also, we have a special DRDO unit, which is making food for the humans who will be going to space. So like that, we are all, the agencies are working together to bring this Gaganyaan project into a successful.
So many trials were done before making them, because we are seeing on a particular day one event, but many trials were being done n days before to make this happen a very successful event.
Yes, ma'am. So now I would like to move on to Mona, ma'am. With the advent of Gaganyaan in the picture, ma'am, Institute of Aerospace Medicine will play a big role in the selection and training of Indian astronauts. Do you think the scope of an unconventional medical specialization, I don't know if it's still unconventional, but like aerospace medicine, has it changed over the years, the scope of aerospace medicine?
It definitely has, Surabhi. So aerospace medicine is a branch of occupational medicine. And when flying began a little over 100 years ago, it took some time to understand that human factors, or somebody needs to check the pilot before he or she is allowed to fly. So that took some time. In fact, somewhere around the first safety feature that actually came in was about 1909, when after a couple of crashes, somebody decided to don a football helmet. And that is where the safety actually started from, 1909. And later on, somewhere around the 1920s, after the First World War, where people started realizing that, not everybody can become a pilot, in the sense of some sort of an exclusion criteria needs to be set in. And whatever, form of medicine that existed, they over a period of time, slowly they kind of started, checking people out. And it is only after the Second World War where aviation medicine, it was called then, came really into its being, when the jet era started. And when the aircraft became faster, is when people started realizing that a lot of physiological problems are happening, accidents were happening, and aviation medicine really picked up. And not only, it's a very interesting branch of medicine, because doctors normally are used to dealing with patients or abnormal physiology in normal environments. Whereas an aviation medicine or an aerospace medicine specialist, my job is a normal person in an abnormal environment. So the very difference lies at what we do. I look at very normal people, and it's just that because human physiology changes in an abnormal environment, is where you have to, know the changes that are happening, and thereafter give some sort of a mitigation so that those problems do not affect either the safety or the performance. Both things are equally important. So it's as I said, a very, very interesting branch of medicine. I'm very glad to have picked it up. There aren't too many people who practice within India or even abroad, but I think with aviation and space also, for that matter, being such a safety critical issues, I think the contribution that we are able to do is phenomenal. A lot of people who practice aerospace medicines also go into human factors, and that is a field where we are able to contribute very effectively into again, where we've spoken about reaches and clearances, about effective vision, or the auditory aspects of different things, where the aviation medicine specialists are really able to contribute over the period of time. And now I'm sure you know what we've been reading in the media, and the hype that was there last year about the first space tourists which went in the Virgin Galactic, and even with Mr. Brosnan and with Mr. Bezos. Actually, the future of space exploration also lies in space tourism. And say maybe in 20 to 30 years, we are actually looking at space hotels. You could perhaps go in a low orbit, say for us, if somebody who's absolutely healthy. So all along now, the focus of space medicine has been, again, what I said, abnormal environment, normal people. But here we are selecting the best of the normal people. But when space tourism will come in, it would be people who have, you know, we've sent up an 80-year-old person. Mr. Shatner went across. So he's, I think, 80, or is it? He's more than that, somewhere around 85. Captain Kirk from Star Trek. So actually, again, the speciality will also have to evolve, where we are able to include more and more people. So if a person is, you evaluate a person with whatever illnesses a person has, whatever medication a person has, but if a person wants to become a space tourist and has that much money to blow up, then why not? So it's changing. It's absolutely a very, very interesting time to be an aerospace medicine specialist. Absolutely.
Yes, you have brought a very important point about space tourism as well, and the whole of India and all the agencies spread across would have to come together in order to bring this kind of space tourism from India as well. I know recently IISc has been included for the studies of human factors, and when I visited the Institute of Aerospace Medicine, I could see that there are many machines over there, like the centrifuge and the hyperbaric chamber, which have been used for the normal people as well. So that is a spin-off for orthopedics, or
a lot of things which we are able to say pass on to the advancement of medicine, or some treatment modalities that are coming through with this, of course.
Yes, ma'am.
There is.
So thank you, ma'am. Now I would be going to ask Kamaljeet Kaur ma'am again about, since she's a distinguished pilot in the panel, I would like to ask you, in all your years of experience in the Indian Air Force, what has been your greatest challenge in the journey as a pilot?
Ma'am, if you talk about the pilot, see, the career progression of a pilot depends on the way you perform. Now, especially in case of women pilots, some way down the line, you think about family, and medical category plays a very, very important role in that. So anytime it's on the family way, so that was the most challenging. I have 2 kids, so 2 breaks I have taken in my profile, and that affects, going back to cockpit takes a lot of effort, whether in time and space, where are you posted, whether that unit is able to spare those many hours on, you have to recategorize yourself, because it is all about training, and thereafter performing. So once you take a break of almost more than 10 months, then you coming back to cockpit becomes a Herculean task. So that is not only for me, for all the lady officers, basically, because primary job remains flying. So I have to take a break from my primary job, though I'm working and doing other jobs, maybe ground duties and other things, but professionally that affects most, and that becomes a challenge for for especially, I said, for me, for most of the pilots. Mona ma'am will vouch for me, being an aviation specialist. She knows, because at times for few of the officers, once they come back, there are complications. So coming back is not that as easy as it looks. So these are the challenges which women pilots face. Thank you.
Mona ma'am, would you like to add to some of the probably the reproductive issues, if they could be of concern post space flight?
You asked a very interesting question, Surabhi. we've spoken about how many women astronauts have gone till now. So the figure was about 74, and total astronauts would be somewhere in the vicinity of about 600. So which came to about 15-16% of people. And most of this is from US only. So it's either US sponsored or the astronauts that have been sent by NASA. So the average age, when I read up for these women astronaut candidates when they were enrolling into the system, was about 32 years. By the time they were kind of returning, going. So obviously, 32 is, as far as having children. Is probably the peak time, because as the maternal age advances, the fertility issues start happening. It becomes a little more difficult to conceive and to carry through a safe pregnancy. So already, it's around the time when a person is coming into the astronaut program. It's, as I said, about 30 to 33 years. So in the process, a lot of these women astronauts have delayed their pregnancies. And although they have been successful pregnancies afterwards, see, there are several issues that actually come in. One of them is the galactic radiation that a person goes through in outer space. So whatever said and done, whatever protective mechanisms that would be put around the space module or the spacecraft or the International Space Station for that matter, the longer a person stays in space, the more amount of galactic radiations a person is going to absorb. And the thing with the women is that we are born with the number of oocytes that are there, or which are potential the cells which can form the babies. It remains steady through the life. In fact, it's steady, rather I would say it starts the number of oocytes keeps reducing as a person keeps growing older. So if a person was to be exposed to a long-term radiation, there could be a problem. One is destruction of the cells, and one would also be worried about this affecting the DNA that is there in the cells. So it is definitely a cause of concern. So as I said, but it's not impossible. It's not that if somebody really wants to become an astronaut and still wants to have children, then now the technique for the past about 20 years is there of basically ovum harvesting. Basically, so the ova are harvested and they are just kept in a deep freeze. And when the woman decides to have a child, they're available for her to conceive naturally thereafter. So the reproductive issues would come in there. Hormonal changes do happen when a person goes into space. Basically, one is the issue about the light-dark cycles. So every 40-45 minutes, the aircraft is or the space module is circling the air. So circadian rhythm disruptions start happening. That translates into the menstrual cycles getting disrupted. Hormonal changes also happening. So a lot of women astronauts actually choose to go on the oral and of course having periods in space in itself is a big issue. So because so a lot of astronauts, women astronauts actually choose to go on the oral contraceptive pills when they are in the air. And once they come back, as I said, there have been about 10 to 15 successful pregnancies thereafter. But if the ovum harvesting has not been done, and anyway they're a little older now, somebody's trying to conceive at 38 or 40, the age-related issues in themselves come in, and the numbers are too small for us to say whether it was spaceflight which caused the problem or was it the late maternal conception age. So there would be issues, but there are ways to counteract this. So that should not be the ladies the potential astronauts point of concern. These are issues can be addressed, but hormonal changes and other issues do occur. So that we have to be aware of.
I think you are mute.
Yeah, in the audience there are a lot of men as well. Ma'am, can you also throw light on what kind of challenges or changes, difficulties would men have to face in long duration missions? Also, when we are talking about humans going to Mars.
Okay, the changes that are occurring, I've spoken about cardiovascular deconditioning that does happen. So that is offset by enough cycle ergometers are placed in the International Space Station. So some sort of resistance training there. Each astronaut is supposed to spend about 1 to 2 hours every day and undertaking exercise. So then the challenges there are is of the muscle atrophy that is occurring. So that also is of course offset by these exercises. The calcium loss that happens it makes people, both men and women, prone to getting kidney stones. And again, we have gone through a very rigorous selection process, but everybody is worried about a medical emergency in air. So again, there are a lot of research is going in about how, if we need to at some stage administer anesthesia, you could train a person for a little advanced medical procedure, but how medicines behave in zero gravity, basically the pharmacokinetics and the dynamics of it, it's a little difficult to study and it's a little difficult to predict. So again, research is happening constantly about medical emergencies. Then the orthostatic intolerance that I had spoken about, also the galactic radiation that I've spoken about, that also would cause some sort of reproductive issues as far as the men is concerned. It does have an effect on the basically again, the shift of the fluid that is happening that tends to raise the temperature in the gonads for the men, and also the effect of the galactic radiations, which could cause issues. So, but again, people have come back, astronauts have come back and have had children thereafter. So some concerns are there, some issues are there, but that is not what should be deterring. In fact, for that matter, because of this exposure to this galactic radiations, there is a 3% extra the cancer threat that a person, kind of increases the chances of having cancer by about 3%. So some short-term issues are there, some long-term issues will definitely be there. Another issue that people would face is isolation. Actually, trying to live with a group of about 5 to 6 people, and what's confinement has its own issues. And it's not that if I have an issue with a colleague, I can just storm out and come back and settle the issue the next day. Here, you are living and sharing the same space, so that will be a huge challenge. Confinement, isolation, mental health challenges that will occur, and of course, we had spoken about this earlier. Women are actually better at handling isolation and even mental health challenges. So one of the reasons why all women crew could go to Mars is, of course, this as well, the ability to handle stress and isolation. But that will, whether it's a mixed crew or a single gender crew, these issues will all be there. It is just that constant training will have to be on, and of course the people who are going to finally be selected are just going to be better of us all.
Ma'am, I have read it somewhere, like once after coming back also they have some like interaction issues, like when coming back to the family, they are feeling isolated and they don't want to interact with the family members and keep quiet. That kind of issues are also being created. That's what I have read.
That issue is very much there, and a lot of these studies or extrapolation that is happening as far as space studies is concerned is also with Antarctica. Our missions to Antarctica, and similar issues are experienced there. And of course, the longest study, if I'm not mistaken, is about 560 days of a group of about 5 people. This was done in Russia, about 560 days of 5 people being isolated in this module, where they were even trying to grow their own food and all that. But interpersonal issues start, actually, it's challenging. So of course, it's very easy to say we will train people and we will, have mature people, but finally, we are all humans at the end of it all. So, issues will crop up. It is just that the constant contact with the earth and people, the family members being very supportive, it will be required. And the readaptation, it takes time when you come back, both mentally and physically. We've spoken about the physical aspects, but the mental aspects are equally important. It happens to people. So it will take some time for them to readjust. Yes.
Yes.
And here I would like to also bring the attention to the kind of training that is being done in the analog sites. So there are Mars analog sites, and which actually simulate the environment of different planets, for example, Mars, and keep the people in isolation on different parts of Earth. There is an isolation analog site in Hawaii, probably we can do also in areas like Ladakh, where there is a little flora and fauna. So we can also look from an Indian perspective on how we can do that kind of training when we do the isolation training as well. So now we are at the end of the moderated panel session, but let us open, because we have a few minutes, let's open the floor for any questions from the chat. Those who are interested to ask questions can kindly raise their hand, and the organizer will give them a presenter, yeah, so that they can write it in the chat. So ma'am, I can see one question to Smitha ma'am. There is a pilot and human crew module mounted on rocket. Can you tell what kind of works pilot in doing human?
Is it related to crew intervention, what he is asking for? Like, maybe I think.
Yes.
Like unlike as you know, like unlike aircraft, our launch vehicle is going through a span of different Mach numbers, going through different transient conditions during the atmosphere. So it cannot be fully controlled by the crew sitting on top of the launch vehicle, like stage ignition or separation events. Those kind of things cannot be controlled by, because it has to happen in a very fraction of seconds. So those kind of things we cannot give it to the crew. And of course, when the crew has certain health issues, or if the co-passenger is having certain health issues, then if a fire is detected by the crew himself, not by the fire detection system, he can intervene with the autonomous system, giving a flag telling that I need an abort. So which will be observed by our health monitoring system, and process it and raise an abort flag. And if it is during the atmospheric regime, our crew escape system will do the necessary abort, or if it is beyond the atmospheric regime, our service module will do the abort regime. Once in on orbit, again the service module will come into the picture for doing the abort. So definitely, as per the human rating mandate requirement, the crew should intervene with the autonomous system residing within the launch vehicle and provide necessary input for the initiating an abort request.
Okay, thank you, ma'am. Now this question is addressed to the IAF personnel. Is there a special diet regime for higher G flights? Maybe Mona ma'am, you can, or Kamaljeet ma'am, any one of you can answer.
Ma'am, especially regarding the flight, in any case or any flight, if there in the basic training, they tell us that empty stomach should not be there. So the protein-rich diets in smaller amounts have been defined for our kind of flying. However, in the space, the research would have been done. Maybe Mona ma'am can add on that aspect related to space diet.
See, as far as the high G flights, say fighter flying is concerned, you don't have anything specific for high G, but we have something for long duration missions. So, one would be, there's certain kinds of things which are to be avoided. So the fried food or food that tends to produce gas in the stomach is food that needs to be avoided. Similarly, even in space, because the motility of the intestine kind of reduces. So there will have to be food which has, of course, will have to be, palatable. They day in and day out, if that is the prepared meals in whatever form, if they are being fed, they'll have to be palatable, but also they'll have to be bulk forming, so that the motility issues of the gut are taken care of. So special diets are planned, and you obviously want a food which is non-irritating, which will not cause problems in the long run. And so this is the kind of aspects that are kept in when trying to design a flight, whether for space flight or whether it is for the high G environment. But the initial lot of food that had come in is it actually in the form of, I'm not sure what ISRO is doing, but it was in the form of paste. A lot of food was pasted because you don't need to prepare, you just kind of need to heat it up. But I think over a period of time, a lot of research has been done, so different form of food preparations have come in, and especially with the international space flight, when every time when the crew is changing, some fresh fruits and vegetables are taken so that they can be consumed, and all the various kind of deficiencies as far as the vitamins or the minerals is concerned are taken care of.
Okay, Thank you, ma'am. There is also one important question to Mona, ma'am. Is it considered that the lifetime radiation exposure limits for women are lower than for men? Can you please elaborate on this? And does it have any implications on the participation of women?
Yes, the lifetime limits for women are lower. Again, basically, we don't have enough a database to kind of raise the limits, so as to say, because as I said, there are more men than there have been women. So again, with the female reproductive system being what it is, and the women are born with the set of oocytes that and as I was saying, subsequently these oocytes don't kind of multiply. So it is better to be cautious, and it's a considered decision that's been taken that the lifetime exposures have been set down lower till we know a little better. But it's very difficult to kind of carry out research. We'll only have to build up databases. No kind of research can be carried out on live human subjects. So whatever research we have is either on analog, so it's probably done on rats, or whatever the astronauts who are coming back. So that's why the limits, keeping the issues that can happen, as we've spoken about DNA changes. So overall, that's why the levels have been set down lower.
Okay. Thank you, ma'am. Now, I would like to ask Avinash to unmute yourself and ask the other question that you were asking.
Good afternoon. Am I audible?
Yes.
So my second question here is, Russia or Soviet Union sent the first women in space in 1963 and has several firsts to its name during the entire space race. However, there have been only 5 Russian women cosmonauts so far. What is the reason for the small number of women cosmonauts, considering the fact that Russia was the pioneer for women space travelers? Thank you.
Would anyone like to answer that?
On this question, actually, a lot of the constraints that come in is integrating women is basically because of issues like in spacesuit design. In design of the various kind of controls or various kind of switches, designing of you'll have to, if you want to have more women, things will have to be designed separately. So I remember reading somewhere when I was meeting up for this panel discussion is that a couple of years ago there was a space flight, extravehicular activity that was planned by the US. 3 women were supposed to go out, and they did not have 3 suits which were of the correct size for all 3 of them to do it. So basically, a lot of it is design issues, human ergonomic issues, and integrating more women into the. Obviously, the design of the whole suit will have to be slightly different as far as taking into consideration, say, the urinary tract system of women. So physiological issues there are, as well as the ability to having lesser forces that a person can generate to, say, operate a particular switch, and so on and so forth. So basically, it's ergonomic issues that have prevented more women to come into the space flight.
Thank you, ma'am. As engineers, we understand that we would have to do double the work maybe to design the systems, but we should also understand that it is equally important to do that. Is there any other question? Sunil, Mr. Sunil, can you unmute yourself? Okay, I will ask the question of Mr. Sunil. Is there any whole body vibration training for crew trainees apart from the centrifuge?
We do have a whole body vibration system for training in IEM. It is available. And the astronauts and the pilot trainees are all trained on that particular simulator. Yes, it is available.
Okay, there's another question. Is there any provision of alarm system for astronauts for daily routine? I don't understand this very well.
Yes, I think it is being provided. The time-based and the alarms are being provided, and also, as you see in the Crew Dragon, there is on the suit they will be wearing a modified iPad, which will where they can log the systems what they can do, and they have a dedicated app sitting on the at the iPad, creating alarms for so and so at a particular time what they have to do, and they can in turn log the systems also. They can even take the photographs with that. Those kind of provisions are provided, so that they need not go on touch on the panel sitting on the top. On the pad, it's on the thighs. They will be wearing that pad, and they will be doing their entries as well as getting alarms for their provisions according to whatever they want to do.
Okay, so yes, Mona ma'am.
Yeah, I'm sure this kind of a thing would be needed because the day and the night cycle that we know as on the Earth doesn't exist there. So depending on how well it is going around the space craft is going around the Earth, the time duration, the cycle could be, I think, about 45 minutes to about 2 hours. So these kind of things to set up a routine and also get the body's systems into some sort of physiological sync. These kind of systems would be needed. So alarms or something to tell them this is day, so you start to work, and this is night, and you need to sleep will be required.
Correct, ma'am. You are absolutely right.
Okay, ma'am. So we are already at the end of the session. There are a lot of questions coming. Maybe we can take these questions and later forward it to you and get it back to the people if time is a constraint. So now I would like to ask Shaijumon sir from IIST if you would like to say a few words before we end the session with a formal vote of thanks.
Yeah, good afternoon, Surabhi. Thank you for that invitation. Actually, I'm really very happy that such a program is organized by IIST Alumni Association. All these very experienced and important women achievers that they share their experiences, which definitely that I believe that which will motivate not only the alumni but also a lot of IIST students I can see, and faculty members are all joined here. So it's such a wonderful program. I personally myself, as the faculty coordinator from IIST, I would love to extend a heartfelt thanks to all the panelists who are brilliant, and the way they answered into a new domain of new area of space science and technology. Also, I personally thank our honorable chairman, ISRO. He has given, actually he's such a motivator, and he has actually set the whole ball going on in this meeting, and to the Lalithambika madam also. So I mean, I'm not thanking, it's officially thanking by the Alumni Association, but really, see, I was listening to the whole discussions which is going on. I think I would urge the IIST Alumni Association to organize more such programs for our students also, that will motivate them to this kind of career, to the diverse career. Because I was actually asking my daughter also to listen, and she was listening, and she said that it is so wonderful to listen. These people in their young age itself, they are capturing all these things, like new things that you are describing. Thank you, ma'am. Thank you all. Thank you all very much. Thank you so much for this opportunity, Surabhi. Thank you.
Thank you, sir. Now we would move on to the formal vote of thanks. I would like to invite Sharvi to deliver the vote of thanks.
Am I audible?
Yes.
Good afternoon, everybody. We have come to the end of a very engaging and enlightening session on the topic Women and Spaceflight. It is my privilege to have been asked to propose the vote of thanks on this occasion. So I, Sharvi, on behalf of the IIST Alumni Association, extend a very hearty thanks to our keynote speaker, Dr.V R Lalithambika ma'am, former director DHSP, for gracing this occasion with her keynote address. Thank you, ma'am. I take this opportunity to express my sincere thanks to Shri.S Somanath, Chairman ISRO and Secretary DOS, Chairperson IIST Governing Council, for having spared his valuable time to be with us. Sir has inspired us with his address, and we will continue to look up to him for guidance and inspiration. Thank you, sir. My sincere gratitude also to Dr. D. Sam Daya, Director IIST and Director ISU, for his constant support to the activities of the IIST Alumni Association. And I also express my hearty gratitude to all the ISRO Center directors and other dignitaries present on this occasion with us. I would like to thank all the panelists of this session for taking time out of their busy schedules to participate in this panel discussion. We have received invaluable insights into our topic, Women and Spaceflight, from your personal and professional expertise. Thank you all so much. I would like to record our sincere gratitude to Wing Commander Ashish Moghe, PRO, Indian Air Force, for helping us with the process of getting permissions for the panelists. My sincere token of gratitude to MSA and administrative staff from various ISRO centers for sharing the message and promoting the event to make it a grand success. I thank all the ISRO and IAF personnel with us for their esteemed presence and participation in the event. We acknowledge with gratitude the guidance and support provided by Dr. Shejmon sir, as well as the computer department of IIST towards the organization of this event. I extend my thanks to the faculty and the students of IIST for their support and participation. A special word of appreciation to the core organizing team, Surbhi, Ankita, Prachi, and Lakshmi, for all your efforts in organizing and managing such an enlightening and innovative panel discussion. I express my heartfelt gratitude to the outreach team, specifically the graphics and social media teams, for their involvement and help. We owe a special mention to Jatin and Ashrit for their valuable help in the event organization on such a short notice. Next, I would like to thank the members of the governing body, the executive body, and all the batch coordinators of IIST Alumni Association for their contribution and support. Last but not the least, I thank all the IIST alumni and other members of the audience who, with their active participation, have helped to make this event a grand success. Thank you all.
Thank you everyone. Thank you Somanath sir for joining us. Thank you all the panelists. It was really wonderful.
There is a message from Somanath sir. Thank you all for organizing this event and fine panel discussion. Regards. So just for the information, thank you.
Yes.
Thank you.
Thank you. Have a good day, everyone.
Thank you.
Thank you.
Thank you so much for your presence, all of you. It was an absolute pleasure listening from everyone. Thank you.
Maybe I think our honorable chairman has joined back.
Yes, sir, would you like to say a few words before we leave?
No, I was all the time there, not John.
Because
it was really
to pass it.
You touched upon various topics. I think the questions were very wide, has enough breadth to cover what the topic. So congratulations for all of you for raising those questions and debating them. It would have been very nice that if you have, I believe that you have already recorded it. It's good that you can make use of it at a later point in time, especially from the panelists who from IAF. They have done really gave a lot of insight on this topic. Thank you so much. Bye-bye. Goodbye then.
Thank you. Thank you, sir.
Thank you, sir. Thank you for your gracious presence. Thank you.